Thanks very much, everybody. I asked Leslie to take up some of my time because, and she failed to take me up on the offer because I happen to be sandwiched in between Leslie, who I think gives one of the more eye-opening talks that you're going to see here at SRM, and lunch. So what I'm going to do is I'm actually going to tell you my take-home message in the first, I don't know, 2 or 3 minutes. And then you can decide whether you want to see the rest of this or not. And if you don't, you can just head off to lunch. I was asked to give this talk, not because you should hear about adaptive management from a plant physiologist, but because adaptive management and EBIPM really do fit together very, very well. And it's the next logical step in ecologically based invasive plant management is to integrate the principles and processes that we've been talking about all morning with the management paradigm that we all really strive to use in our trade. So all adaptive management is taking a scientific look at how we do our management and to use underlying scientific principles to make management decisions. But what we're trying to do with EBIPM is essentially the same thing, and that is take underlying ecological principles and link that into our management as well. The way we do that, and this is the take-home point of this talk and what the rest of the talk is going to be about, the way we do that is we're going to take our adaptive management paradigm and we're going to construct our adaptive management cycle around the ecological principles that we've been talking about before. We're going to use management to influence ecological processes, to repair ecological processes that are hindering the establishment of the desired plant community, and then we're going to monitor and ensure that the ecological processes that we decided were in disrepair have been repaired or are on a pathway towards being repaired. And if not, we're going to alter our management and see if we can't do a better job in the next management cycle. So adaptive management is often referred to as learning by doing. This is probably my least favorite definition of adaptive management because I challenge you to come up with a field of knowledge where we learn by simply sitting on our butts. Adaptive management is better defined, I think, by these next 2 bullet points, where we recognize that it is essentially an iterative process that integrates both management and data collection and uses data and the data that we collect and the knowledge that we gain to improve our management, to improve our actual management techniques. It's an iterative process, meaning that we're constantly doing both management, monitoring, and assessment of our outcomes continuously through the practices we use to manage our land. So why do we do this? One of the early proponents of adaptive management, C.S. Halling, probably summed it up best when he said that the domain of our knowledge of specific ecological and social systems is small when compared to that of our ignorance. And I think that statement says a lot, but what it really says is, what it really helps us to understand is the difference between scientific pursuit of knowledge and management. And, well, we all consider them to be both very, very important. They are somewhat distinct disciplines that are aimed at different outcomes. Science is inherently a very conservative process. Science seeks to learn new information, and most scientists are really, really hesitant to make any actual recommendations on the application of their science until they have lots and lots and lots and lots of information. Management, on the other hand, recognizes that there is a problem that needs to be solved right now. The problem is either bad right now or likely getting worse going forward into the future, and we have to do something. And if we don't do something, it might get even worse. But we're going to go ahead and do it but we're likely going to have to do it when we don't have all of the information available to us on what is going to happen when we take a certain action, okay? And that's because management systems are complex problems. And by that, what I really mean is that the action that you take on the landscape is not always going to lead to the exact same outcome. The relationship between cause and effect in a management type system is somewhat fuzzy, okay? If you do X on a certain piece of land at a certain time, you will not always, if you do X on a certain piece of land and get Y, and then apply that to another piece of land at another time, you're not necessarily going to get Y. What we're trying to do with EBIPM is improve the probability that you do get Y when you do X, okay? By using those ecological principles. So the field is not the lab. And most scientists are seeking laboratory type knowledge. Knowledge that is very concrete about the relationship between cause and effect. But that doesn't happen always in the field. The field is often a much more complex system. And when we're considering management, we also have to realize that we're not only managing based on science. We're also managing based on what is sociologically feasible on that landscape, and we're often managing what is based on what is also economically feasible on that landscape. So the adaptive management cycle is a cycle you've probably all seen before. The adaptive management cycle actually fits very, very nicely into the scientific method, okay? The scientific method, or the adaptive management cycle, starts with, is that the on button? Oh yeah, there it is. So the adaptive management cycle begins with assessing a problem, right? In the scientific method, we consider that to be our question. It then moves into designing alternative management scenarios. In the scientific method, we call those hypotheses. The actual experiment in a scientific framework, in an adaptive management framework, is the actual management actions that you take on the landscape. And those are going to be linked to monitoring, which for scientists we call data collection, same darn thing, and then finally some kind of data analysis. In science, we would then go ahead from our data analysis and we would come up with a conclusion, and we would go off and we would publish a paper, and hopefully 2 or 3 people would actually read that paper someday. Here's where we divert a little bit. From those outcomes, we're actually going to go back and we're going to assess the impact that we have had on the landscape and how we have progressed towards our management goals. And we're going to reassess the problem and adjust our management as necessary to determine what worked, what didn't work, and how we're going to proceed in the future. So the ways we go about doing this is we develop initially some key management questions that are of management significance, that are feasible and can lead to alternative management hypotheses. When I talk to undergraduates about the scientific method, and specifically undergraduates in, say, introductory biology or a very early on class, I really like to emphasize that we're talking about questions and hypotheses that make sense in a biological reality or in a management reality, okay? And I always try and give them some kind of an absurd example to illustrate that there are biological things out there that you might be able to think of that don't necessarily make sense. So if we're standing in northern Utah in, a sagebrush shrubland, a management question that wouldn't make much sense would be to try and turn it into a tall grass prairie that looks something like the Flint Hills of Kansas, okay? We have to be designing hypotheses and management questions that make biological and management reality on that landscape. The plans that we implement have to be well designed. From a scientific perspective, if we haven't designed the project well, if we haven't designed the actual implementation correctly, we may get an answer, but it may be the wrong answer, okay? So by designing well, I mean we have to have done this, we have to be doing this at an appropriate scale, a scale that is appropriate to answer the question that we posed. So if we're examining the effectiveness of, say, 3 different herbicides or 3 different rates of application of an herbicide, we might be able to do that on a relatively small plot scale. However, you're never going to try and implement various different grazing schemes on a small plot basis. If you're going to test different grazing hypotheses, you're going to need a large-scale pasture experiment. Our experiments need to be well replicated, okay? We can't simply do something at one little tiny spot on the landscape and expect that what we observe at this spot is going to apply to, say, a 20,000 hectare ranch. And we need to have appropriate designs that allow us, appropriate experimental or management designs that allow us to separate how changes through time can be attributed to the management actions that we take and separated from changes through time that might be attributed to other factors, such as climate. One way we can do that is the use of a BACI, or a before-after control impact design. And that's simply an experimental design that says we're going to make measurements on manipulated plots as well as control plots. We're not only going to be measuring what happened in our manipulation, but really important in this design is that we're going to measure what is going on in our study before we actually apply the treatment. Okay? So not only do we know what's happening in the not only do we know what is happening in our management relative to our control, we know what is happening in our management and our control relative to where it was at the beginning. And ideally, this is going to be something that you do for several, for 1 or 2, maybe even more growing seasons before you actually implement, that management. So you have an idea of the natural range of variability. When you have an idea of that kind of the variability in the landscape, you can use something called a power analysis so that you can figure out exactly how much effort you need to put into your monitoring to determine or to know if you can even answer the question. Okay? One thing that often happens is monitoring is the first thing to get chopped from the budget. And the problem with doing that is if you don't do enough monitoring, you can very easily have an effect and not be able to detect it. Okay? You're not going to be able to detect it given the background variation in the system. And the last thing you want to do is spend a gajillion dollars out there actually doing management and then not have enough left over to determine if your management has been a success. Because if you can't do that, your adaptive management cycle is going to fall apart. You have no way to adapt to what you have, what you've learned. You have no way to learn. So I have a little hypothetical example here, and my hypothetical example says that we might have a management question or a goal of increasing perennial grass cover by 20% over 5 years. We would then come up with a series of hypotheses which are essentially management alternatives that we could use to address that goal. Remember, these have to be feasible alternatives for your landscape. You might be able to reduce stocking in the hopes of taking some pressure off of that land to see if you get a little bit of regrowth of the perennial component. You might be able to add in perennial seed into the system to see if you can get establishment of species that aren't already present. And you might consider combining both of those and seeing if there's a synergistic effect. There might be some other hypotheses that you could test on that landscape. For example, you might achieve your goal by completely removing cattle for many, many years. That might not be economically feasible, however, on the land that you're managing. Okay? Again, we're talking about sustainable, we want to sustainably manage this land, and if you're not making any money off of it, that's probably not sustainable either. We would then go ahead and establish an experiment on the landscape where we apply those hypotheses, the different management alternatives to different pastures, making sure that we maintain a control. And we would adequately set up some kind of replicated sampling regime throughout the entire experiment, so that we eventually get to the point where we can evaluate some outcomes by crunching lots and lots of numbers and maybe doing some fancy stats, or maybe not doing any fancy stats, that allow us to eventually adjust our management, and in doing so, maybe eliminate one of those hypotheses. Maybe eliminate the addition of extra seed, possibly because it wasn't very effective. Or maybe we go ahead and we add lots more seed because that appeared to be the management alternative that was most effective. But what my example, the example that I just gave you, is really lacking was any link to important ecological processes that may need to be repaired in our management. Okay? The example that I gave you might be termed, using eminent wildlife biologist Aldo Leopold's phrase, intelligent tinkering. Okay? We set something up, we had a couple of management alternatives, and we went ahead and tested it. What we want to do with EBIPM, however, is use the causes of plant community change to design our adaptive management scheme. So we've talked about these causes of community change a couple of times already this morning, so I'll just very quickly reiterate them. The first one is site availability. From the EBIPM model, site availability links very closely with disturbance. And we want to make sure that we're managing for disturbances on the landscape that promote the establishment and persistence of the species that we are interested in. Okay? Here, we're primarily managing for improved production of perennial grasses. We want to get as much of the invasive annual component off of our landscape. And in doing so, and in order to improve that, we're going to strive for infrequent disturbances, that are at relatively low intensity and relatively small scale. And if necessary, we're going to consider moderate disturbances that will create safe sites for the establishment of our desired perennial grasses. The next principle is that species availability influences community change. And we want to make sure that we're taking management actions and designing our management around ways to increase the dispersal of desired species while reducing the dispersal of invasive species. We might be able to use targeted grazing for doing something like this. If we're able to target our grazing towards the elimination of seed production by an invasive annual grass. We might need to consider the addition of seed into the environment so that we ensure timely arrival of our desired species, and so that we can essentially supplement the production of desired species if those species are missing from the landscape. The final cause of change is species performance. So here we want to recognize that we're going to try our best to limit resource availability in that community by maintaining diverse life histories among our desired species, to essentially ensure that the community that we are managing on the landscape uses all of the resources that are available. Resources are left available, likely an invasive species is going to be able to come in and grab a hold of it, and that's not what we want. It's not what we want to see happening. We can use stress to manage these systems as well, recognizing that stressful situations often favor long-lived perennial species over short-lived invasive annuals, which are not desired on this landscape. So we start the process of adaptive management in an EBIPM framework by using what Ed just talked about, and that is rangeland health. And we use rangeland health because before we begin, we have to identify the ecological processes that are in disrepair. And we're going to use this to build essentially our entire EBIPM adaptive management framework around the ecological processes that need to be repaired. So let's say we go out and we do exactly what Ed told us, and we conclude that we have compacted soil with quite a bit of bare ground and some moderate soil loss, and we conclude that perennial grasses are largely lacking from the system. At that point, we've essentially identified the processes that need to be repaired: site availability and species availability. So we could then go ahead and choose a tool to address both site availability and species availability, and we might need to use supplemental seed and possibly some seed bed preparation. Then we would go ahead and design essentially different management alternatives around those processes and those tools. So we might consider possibly different techniques or different implementations of the same technique. If we've decided we might need a little bit of seed bed preparation to break up a compaction layer, we might try the alternatives of minimum till versus a no-till drill. If we decided we needed to add additional species, supplement seed into the system, we might try different seed mixes. We might try different varieties of the same species that are available in the market. We might try single versus multiple seedings, dividing half between an application one year and another year, or putting it all all into the system at once. These are essentially the different hypotheses that we're testing in an EBIPM framework. We're going to use an adequate design so that we can ensure that we can answer the question that we essentially posed, and that is, which of these management alternatives best repaired the ecological processes that were in trouble. So we're going to choose locations that are representative of the landscape, that recognize the natural variability both in the soils, taking into account the history of the site, as well as plant species composition. As I said before, we're going to make sure we choose plots that are appropriate for the size, for the scale of the management that we're interested in doing. And we're going to make sure that we replicate any scheme so that we take full advantage of that representative landscape. We're going to be really careful about establishing our controls. One thing that I really like to emphasize is that the control sites that are established also need to be representative of the landscape. It's totally cheating if you try and put your control sites right near that pile of rocks that you can't get the drill to. Okay? That's not a control site. That's not representative of what you're managing. Okay? Don't get to put your control site up on the steep hill slope where you're not going to be able to get the tractor. Okay? Control plots are also areas where you're not going to be taking any new management action. It doesn't mean that having a control site doesn't necessarily mean that you need to remove management from that area. What we're trying to do is improve our management in this framework. So the control site could simply be an area where you don't add a new management scheme onto it. Okay? Continue doing what you were doing because you want to see if the adjustments that you've made are having an impact. As I said before, you need to have adequate designs, a before-after control impact design where we've measured what's been going on in this system before you implement the new management, as well as after you've implemented the management, both in the manipulated sites and in the controls. And by having that pre and post treatment comparison, that's the only way that you're going to be able to separate essentially what has happened by your management versus what has happened due to background variations in the system. So when it comes to actually deciding what are you going to measure in an EBIPM adaptive framework, think about the ecological principles that are, again, in disrepair. If we're concerned about soil compaction, choose a variable that indicates closely soil compaction, such as infiltration of soil water. Okay? We're ultimately interested in establishing a stand of perennial plants that is going to be self-perpetuating. So we need to know something not only about establishment, but also about seed production. Okay? Seed production was an ecological process that was in disrepair in my example. So we got to make sure that we're monitoring seed production going forward in time. We also may need to keep track of some other ecological processes, perhaps ones that we didn't necessarily determine were the primary problem, but keep in mind you've got a cycle that you're going to continuously be going through. So you want to, as best as possible, make sure that you have some idea about all of the ecological processes that you could potentially be addressing with your management. So then we're going to go ahead and evaluate and determine if there has been a difference between the treatments and the controls, if there's been any kind of trend through time, and whether that trend through time can be attributed to your management or to natural variation in the system. And go ahead then and make any adjustments that need to be made. So you might ask yourself at that point, are there treatments that are clear failures? treatments that just plain didn't work, because you might be able to go ahead and eliminate them from the system. Given what you know, do new treatments now make sense? Is there something else you want to add in the next round of your adaptive management? Have the management goals and objectives been met? And finally, from an EBIPM framework, and thinking like ecological restorationists that we are, we want to be able to answer the question, have the processes that were in need of repair been repaired? Have you actually affected the change on the ecological process that you needed to? Okay? And one other thing to keep in mind is that if you have affected the process that you need to, a new process may emerge as something that needs to be addressed in the next management cycle. Okay? So in fact, if you are most successful and you've addressed site availability and species availability, in the next management cycle, next adaptive management cycle, you might be looking at having to address species performance. Okay? Which is why you want to be monitoring for changes in all of those causes of succession. Usually when I end a talk it says end up there, but this is an iterative cycle. So we're right back again at the beginning of where I started. And with that, at the beginning of my talk, I would be happy to take a question or two, or you can all run off to lunch.